Okay, okay. Thank you. All right. So we'll just revise what we had seen in last lab, and then we'll go along with this lab. And hope I think I have received more than 160 submissions. So I hope all of you have completed the programs, right, successfully again. Okay. So we had seen the concept of system calls in last lab. Fine. System calls are nothing but the way to communicate with the operating system. Right? Whenever we want to invoke OS functionalities, right, uh, we need to call the system calls, right? And system calls are luckily provided as a collection of functions again, right? So it's easy to use them. Okay, and we have seen some set of system calls, and in upcoming labs we are going to see some more, right? So that you can get used to how an OS can be written internally. Fine. So my first question to you is, did anyone try to see what is the actual code of the cat or cp command? Yes. Just out of curiosity, did anyone try that? Yes. You can be honest, right, with me. That's good. That's no problem, right? But basically, what I want, yes, Priyank is asking how to check it. Yes, see, generally the Linux operating system is open source, right? As we all know. Yeah. So the code is mostly available. Fine. If you can download the entire OS, right, the package of the code is again available. Fine. But we had implemented just a part of it, right? I hope you agree. Fine. So what is still missing in that code? Can you tell me what we can add to that code so that it becomes the complete command which we are using on the Linux-based operating system? Its options, yes, that's right, right? So the only difference which is there in the actual code is they have coded for all possible options, right? And again, I think you can now guess that it works with command line argument, right? That program which is running inside your OS, which you are using currently, runs with command line argument, right? Because when you do cat with some option, right, that is nothing but it is accepting command line argument. Now, one more point is when we are typing that command, let us say cat or cp or anything, right? What do you think? A new process is getting created, or it is running in the same process? What is your point of view? Answer that in the chat. New process is getting created. Yes. Child process. Very precise answer generally. Yes. So that is called process creation, right? But as we have not yet completed the process chapter, I'm not going to take that process-based experiment today. That we will see in the next lab. Okay, so that is again going to be interesting. We'll try to create child process using again some set of system calls, and we will see how they can control. Yes, we should have a question. If we only want std out, why we use write instead of printf? Yes. So basically, we should the difference between printf and std out, I think it is clear to you as well. Write is a system call, while printf is a library function, right? You know that difference? Yes. So why we use printf? Because we are working at API level, ideally, right? As a programmer, we are working at API level. But if you want to code the OS actually, then in that case, you will have to work at system call level. Are you getting the difference? Yes? Yes, exactly. Printf internally calls write. That's what I told you last time, right? So that is why we say that printf is at API level, right? Or you can say it is at library level, and internally it is going to call write by default. So as a computer student, you know that write is a system call, right? But the other students who know C, they are generally not aware about write system call, right? I hope you agree to that. Yes, so that is why we are the different persons, right? And that is why we should know both the things. So are you clear with that? We should, because we want abstraction, right? That's why we work at a printf level. Okay, good. So let us start with today's lab. I have a new set of commands today, right? Why we are covering commands in lab? Because as I told you, you can get used to how to use OS related functions and system calls, right? And you can also realize how OS can be written actually internally. Fine. So that is the only purpose of writing the commands in the lab session. Fine. We won't be doing that for all the labs, right? But command-based labs will have for at least 3 to 4 lab sessions, right? Other than that, we'll carry out labs on process, threads, and etc. Okay, we'll see that as soon as it comes. Okay. So let me share the lab 2 manual with you. I will also upload that in the classroom so that you can use that for your submission. But after we discuss, right, I'll upload that. Okay, so I'm sharing the slide with you. Sorry, the PDF, yes. Okay, so again, this time we are taking a break from system calls. So I'm going back to library functions, right? But these library functions you have not used up till now in C programming, right? So there lies the difference. So we will first focus on Pwd command, right? So can you tell me what Pwd does? Most of you have written or you can say practice that command is your first command in your computer's lab, first semester. Present working directory, exactly. And by default, what is generally the present working directory? When you are logging into the system, slash home, exactly, right? Slash home. Inside that, if you have created any other directory, slash home user, yes. Slash home user, yes. And I think all of you have worked with our labs, right? Where we are doing CentOS. Remember the lab sessions which you had? Yes, right? So anyone remembers that output of PWD which we were getting? Slash home slash, what was that? I know it has been a long time, but if someone remembers, user one, that's right. Very good, Harsh. Right? So user one was our username and user10702. Right? That was the password. I hope you remember that. Yeah. Okay, so if I want to print my current working directory, I just need to type in pwd command. Okay, does pwd have any option? Anyone knows that? Do we have any options for pwd? Or it is just a plain simple command? Yes, it has -p, right? But we don't use it often, right? We generally use pwd. Yes, there are some other options also. Yes, right? But again, we'll keep it simple, right? I don't want to make the things complicated right now, so we'll try to implement at least the basic command which we can achieve. Yes, exactly, -h. Okay, so which is the function that runs in background, right? That does this job. Okay, so for that we have one function called getCwd. Actually, when you open the main page of getCwd, you will get a complete list of functions, right? But the most common function which is used for writing the pwd command is getCwd. Okay, so last time we did not have that time, so today I will take more time to explain you the signature. Okay, so when you are studying a system call or a function, first thing you should focus on is the header file. Okay, so always remember this rule because this will be useful to you whenever you are reading the main pages. Okay, first find out what is the header file. Over here it is unistd.h, right? Did we have this one last time also? Unistd.h? Yes. For which system call? for read and write as well. That's right. That's right. So unistd.h is actually a very useful file. It is supporting system calls as well as functions. Remember, getCwd is not a system call. It is just a function, okay, of your C library. Fine. Still, it does an important function, right? Okay. Next thing you should find out is what is the signature after reading the library. Okay. So signature says that we have a return type of character pointer. The name is getCwd. Argument is buffer, character pointer, buffer again, like we had last time, and the size. Okay. So you can again go with the last time's technique. We had declared the character buffer of size, let us say 50. Okay. And that buffer you will be passing over here. Okay. So it takes an argument as a buffer. So what is the use of this buffer? Can anyone tell me? What is the use of buffer which we are passing? It is acting as a source buffer or destination buffer. If you understood the signature, it will contain the absolute path name. Yes, so that means it is written over here. That's right. It is destination. Fine. That means it will contain your current working directory name once this call is successful. It will contain your present working directory name once your call is successful. Okay. And we also need to give maximum size of the buffer so that we don't run out of the memory. Okay. Another thing is why we are having the return type. Yes. What is the purpose of having return type over here? Character pointer is a return type. So what does that signify? It returns pointer of path, returns path for write. Okay. So actually it returns the same thing. Right? By same thing, what I mean is it will return the name of your current working directory. Right? So this function works in two ways. Right? You are going to pass a empty buffer, right? And that empty buffer will contain your path name, okay? As well as this function returns the path name as well. This function returns the path name as well, right? Yes, you can say that, Harsh, but actually, if you have declared a character pointer, let us say S, right? And if I'm calling S is equal to getCwd, right? That means S will be pointing to the name of current working directory. I hope you get it. Yes? Yeah. So, my next question is, can I use this function by only passing the argument? That is, if I don't use the return type, will that be sufficient? If I don't catch the return value, then also, will it be fine? Yes or no? Okay, Harsh is saying no, Deep is saying yes. What about others? Priyank is saying yes. Okay. Yes is also saying yes. So that I am leaving up to you. That is your first task you need to do. Okay. Call this function, right? First, without catching the return type, and then you catch the return type and try to print the value, right? And then see, are you getting any difference or error or something like that? Okay. So are you clear with the signature of this function? Yes. The example is given to you. Yes, sure, Juzar. See, what we are going to do is understand this line I have written over here. X is equal to getCwd path size of path. Now, what will be path over here? It will be a character array basically, right? Last time what we did, we were declaring a character array of a sufficient size. Okay. So, and then the size of the array I'll be passing over here. Okay. So, size of path. So, after this call is successful, path buffer will contain name of your present working directory, right? As well as that is returned as a return value of the function also, right? That same current working directory name is returned as the return value of the function. So if I try to print value of x, let us say x is a character pointer, character star x I have declared, okay? And if I do percentage s, printf percentage s, and x. So will you get the same value as of the path, or it will be different? What do you think to that? Same, exactly. So that's what I want you to verify. Right. Another thing is, if I don't write this x is equal to, if I'm just doing get cwd path size of path, will that call be successful? Is the question clear, Rizal? Right. So these two things you need to verify. So write down a small program. I'm giving you enough time. Okay. And just call this get cwd function and make sure that your output is same as Pwd command. First run Pwd on your console, right? And then write your code. Make sure that your output is same as that. Okay. Get wd is again another variation of the same function, right? But as I told you, this and the third one are not often used, so we'll be using the first signature, character star get cwd. Okay, so go for it. I'm giving you enough time, and once it is written successfully, you can write that in the chat box that pwd over or pwd done. Yes, path should be empty. Yes, definitely, Shail. It can be. Uh, you can say you can declare a character array like this, right? Character str, let us say 50. Yeah. So it will be empty definitely, right? And inside str, it will store the present working directory name once this call is successful. Okay, so that is it. So do it and let me know once you are done. Yeah. I think you can take around 10 to 15 minutes for this. If you need more time, don't worry. I will give it. I will give it surely. But report your status once you are done. It is just a 3 to 4 lines program, so it should not take more time. So your first program for this lab is this one, right? Write a program to get current working directory name of the current process. Right? That means you are inside your shell, that is your current process. Right? So inside current process, what is the output of PWD? That is what you need to print. We are going to write 3 programs today. This is the first one. Good, Bhavik. Yes, so I'll wait for some more time, right, as I told you. Then we will go with the second program because that is more important than this one. This is just a small task I wanted you to perform so that we can get used to the uh, again man pages and all. To store, we need to use reference. Not necessary. Not necessary. You can directly store that inside the array. Right? Although in the signature it is expecting a pointer, but last time we have seen that if you use an array, that is also fine. And right now we are not allocating the memory dynamically. If you want, you can also do that. But our goal is to learn the concepts, uh, the basic concepts of OS. That's why we are not going for that dynamic memory allocation only. But if you are fine with that, you can go along with that, right? No problem. Okay, Ronak is also completed. Good. Okay, so I'll be waiting for the other's status and then we'll go for the next one. Yes, okay. I'm receiving multiple responses. Nice to see that. Yes. So those who complete, I'm giving you the next task. I assume that all of you who have completed uh, are working on Linux, right? And you have access to your man pages as well. I hope you installed the manual pages. Yeah. Okay. So if you have completed this first program, I want you to read the man page of OpenDIR. OpenDIR. Good, good. I'm receiving multiple responses now. That's nice. I'll wait for 5 more minutes. Then we'll go along with the next task. Okay. So OpenDIR. Go through the manual of that. If you have finished this program early. Okay. I'll wait for 5, 6 more minutes. Then we'll go along. Yeah. Keep writing your status over here once you have completed, right? Yes, actually, I was going to ask you that question at the beginning. Manual entry 2 is for system calls cable. That's what we have seen last time, right? And manual entry 3 is for functions, right? So definitely, this is in section 3. Just verify and let me know. Right? Yes, it has to be there in manual 3, right? Because it is library function. So that rule you need to remember for all the labs, right? If you are not writing any number, that means it is a command. Man cat, it is a command. Man 2, read, that is a system call. Man 3 and the function name, that is a printf, that is library functions. And I hope those who have completed have verified both the things, right? Return value and path argument, both are giving you the same results. Try to print both the things, right? Yes, good, good, good. That's nice. Okay, nice to know that you are getting same results. Good. So 3 more minutes. I'll wait. Meanwhile, you read with or read the man page of OpenDIR, Open Directory. And again, as per the standard practice, which you have submitted, again, whatever functions or system calls we discuss, the theory you will have to explain in your own words. I don't want you to copy it from this document, neither from the main page, right? The only thing you need to explain is write down the syntax of the function with everything mentioned in the main page and explain what are the arguments, what is the return type in your own words. And in 1 or 2 lines, explain what that function does. Okay? So no need to copy the same from the main page. Right? If you are copying, then there is no meaning of submission. I hope you agree to that, right? Because from your submissions, what I want to assess is how much did you understand, right? So make sure that when you are writing the theory part, you should be writing in your own words. Okay. So for the first part, you need to write the theory of get CWD, right? And then your program definition that is given over here. Okay. And then you need to copy the program code plus the output. Okay. If you have taken multiple outputs, make sure that you are including multiple outputs. Okay. So I'll wait for 1 or 2 more minutes. I hope the others are doing. Anyone else has completed? Please report your status if you have completed. Those who have not replied. Yes, Priyanka, I had seen your response. What about others? All others, those who have submitted earlier, the response I have seen. So you don't need to repeat. Yes, Akshay has completed. Yes, Harsh. Okay, good, good. Fine, fine. So I just want to know that you are able to complete. For manuals, man command. Exactly, Priyank. Yes. Man is a short form of manual. Yes. For print, yes, yes, that's okay, yes. We can stick to library functions over here because again we are using get CWD, which is again a library function, right? So we can, for this lab, we can stick to printf. Whenever we'll go for write, I will inform you. Okay? Till that you stick to the standard functions. Yes. Because we are going to study a lot of things, right? A lot of system calls and a lot of functions. So whenever the time will come, I will inform you accordingly. Okay, any difficulties that you are facing until now? If you are not completed with the program, you can write that. Okay, I think now most of you are clear. So let me describe the next task because that is going to take some time uh, for the study part. Right? Okay. So next task is again a question for you. All of you have used ls command, right? There is no one who might not have tried that, right? What ls does basically? A short definition of ls is what? What is the job of ls in brief? List directories and file. Very good. That is a precise answer. Yes. Now, if you remember, right, the first semester, or you can say the basics of Linux, right, we have a concept of current directory and a parent directory. Remember that? Current directory and parent directory? Yes. So, generally, what Linux does is current directory is represented as a dot and parent directory is represented as a double dot. Have you used that? Yeah. I think in first semester you must have done that, right? Yes, CD double dot you might have done, right? Or CD dot slash. Yes, yes, exactly. So dot and double dots are also directory names. Can I say that? Dot and double dot are also directory names. Yes, right. They are again directory names, and every directory in your file system will have these two entries. Agree to that? Every directory inside your file system will have a dot and double dot. Okay. So when we do ls, except root, yes, exactly. That's a correct point, Chitan. When we do ls, right, are we getting the entries of dot and double dot printed? Just try that on the console for your directory. And yes, when you type ls and press enter, are you getting dot and double dot? Gurjit, are you clear with the question? Yes, you are not getting, right? That means the C code, which is running the ls command, is actually suppressing those two entries, right? The C code, which is, yes, ls minus a, because it is printing everything. That's right. That's right. So the basic ls is suppressing those extra entries. Agree to that? Yes, right? So we are going to write that program, right? Is that interesting? We are going to write that program, what ls does, right? And we will try to mimic, right? Actually, ls gives you a formatted output, but at least if you can get a one column output, then also I'll be happy. Not option generally. That is, you can say, a long way. but we can at least implement simple ls, right? That will be sufficient for this lab if you can do that. Yes, and I'll be more than happy with that. Okay, so the first function we need to study for that is an open directory, right? So let us come back to the main page. Open directory is a function. First, as I told you, focus on the header files. There are two header files, types.h and dirent.h. Okay. Generally, types.h is used when we are using specific types of devices or specific types of, you can say, external things. Okay. So basically, over here we are dealing with directories. So that's why types.h is included. Okay. Dirent.h is a special header file which maintains all the functions as well as the pointer definitions regarding directories. Right? So direct.h is even a critical header file when we are working with the directory based operations, right? Because it declares some structures, it declares some, you can say, function definitions inside the header file. Okay. So remember, when you want to start writing ls, the first thing is we have to open that directory, right? Yes or no? Yes, because when I simply type ls, by default, which directory it is going to open? By default, which directory it is going to open? Current. Yes, right? And that's why we have covered that get cwd function first, so that you can know how we can get the current working directory, right? In your program, initially you can start with passing static file name also, static directory name also, right? That's not a problem. But later on, you try to make it dynamic. That is, if I'm passing some name, then it will take that specific directory, or if I'm not passing anything, right? And then in that case, that program will run for current working directory. I'll explain this later, don't worry. Okay. So these are the header files. Next thing is the signature. So let us now focus on the functions internals. So open dir, then we have constant character pointer name. Okay, constant you are already aware in C, so I'm not going in that depth. But main thing is character pointer name. So what we are going to pass over here, can anyone tell me? It is a path of directory, exactly. Suppose I want to open /home, right? So I'll be passing /home as a static name. Okay. If you want to work with current working directory, so you can call get cwd function, and whatever you are getting, that should be passed over here. Is that much clear? Arguments part? Yes. Important thing is the return type. It returns a directory pointer, right? Now the directory pointer's definition is stored where? What do you guess? Where this pointer should be declared, or where it will be declared? In direct.h, exactly. Good, good. So direct.h is a data structure declaration file, plus it also declares some functionalities, right? Okay. So using this directory pointer, what we can get, right? Let us read that detail. It returns a pointer to the directory stream, right? And what does that mean? It points to the first entry in the directory. It points to the first entry in the directory. Okay, so whatever is the first record in my folder, it will be pointing to that. Is that much clear? What is what is dir pointer and what it does? Is that much fine? Yes? Okay, I'll repeat, Urjit. Directory pointer, yes, surely. Directory pointer is a special data type declared inside direct.h. Okay, so suppose your folder is having three files, let us say a.c, b.c, right? And let us say e.c. Okay, I'm having three files in my directory. Okay, and I assume that a.c is my first entry. Is that much clear, Urjit and Jatin? A.c is my first entry. Yes. So after this call is successful, that means after open dir call is successful, this directory pointer will be pointing to the details of a.c. What are the details? I will explain that later. Right? Is this much fine now? You will be pointing to a.c. Right? You will be pointing to a.c. Is there any way to open direct.h file? Yes, you can open that, but it's a header file, right? So right now directly it would be possible to open. You can still view the code, I guess, right? Yes. Okay. So I want you to write a small program right now, right? Just pass static directory name inside OpenDIR, okay? And check whether you are able to open successfully or not. Whether you are able to open that successfully or not. You can try that for /home, right? Yes, surely, Janil. You can try that for /home/user directory, right? Right now, I think you all might be having this directory, right? /home, at least /home might be there, right? So what you need to do is inside OpenDIR, pass this name statically as a string, okay? And check whether that directory is successfully opened or not. Is that much clear? Yes. Now the question is, how will you check? Right? So for that, you can see this. It returns null on error. Exactly. It returns null on error. That's right, Janil. So if directory pointer is not null, that means what we can say? Open is successful. Yes or no? Yes. Yes, Krishil, that's right. But directory pointer, it is a pointer type. Right? So you need to declare that as a pointer. Right? So you need to declare like this: dir star bptr, let us say, right? Yes, star fp, exactly. Okay, so can you do that much? Open a directory and check whether it is successful or not. Okay, good, good. Jenny is already completed. That's nice. Others do that quickly, right? And then we'll continue. Yes, Juzar, because libraries are same, so I don't think there should be a problem. But right now, you can stick to C program, right? If you have the C compiler, I better recommend that you go with C programs, right? .c only. Because in the upcoming labs also, we'll be sticking to C only. So I prefer that you go with C as of now, right? Yes. All the labs we are going to do C programming, right? So the advantage is your C programming will get further better. Right? Plus, you will be able to learn how to write OS functionalities. Yes, good. Bhavik has done. Ansh is also done. So that means you are able to open it successfully, right? See, basically, whenever we are working with pointers, what is the error that we might encounter? You must have faced that in your first semester when you were here with CentOS. What is the probable error if you are not handling pointers properly? Yes, permissions are there, but yes, segmentation fault. I was looking for that. Yes, I hope you remember that, right? So I want you to avoid that right now. Okay, that's why we are going step by step. Because when we are working with directory pointers, again it becomes critical. Right? Because if the memory is not properly allocated, you will get segmentation fault. Okay, good, good. Many of you completed. Very nice. So I'll wait for 2 more minutes, then I'll explain you the next function. And meanwhile, you start reading read dir. That is the next one. Read dir, again man 3. Man space 3. read dir. And as I told you, follow 3 thumb rules, right? First rule is focus on the header file. Second rule is focus on the signature. Third, see what it returns, because we will also be interested in checking whether our call is successful or not. Right? So like over here, you might have checked with null, right? So always read the manual in detail, right? Okay, if you are getting not success, then I think you don't have privileges to open that directly. Can you try it for other directory? Try changing the paths, right? And then see. Yes. Because see, if we don't have privilege, then again we will be denied access, right? So that is possible. So that's why I told most of you that you should work with your home directory, right? Because we are the owners of home, so that should not be a problem. Good, good. Yes, and Prince have completed. Okay, if you don't have home, then what is your current directory? Can you type in that name over here? Just type pwd and check your current working directory. Yes, /mnt/c. So you can try with that name, right? Right? Because over there you can do the operations, right? Yes, yes. Okay, now I'll continue with this. Yes, if he is doing on HTTP, then there can be issues. I agree, yes. But then let us see. Otherwise, child, we need to find out some other solution if it does not work out, because suddenly you have complete rights on the home directory. That's why I told you to go for that. Okay, so read dir. Okay, good, good. So inside the read dir function, if you see, again the header file is direct.h. That means we are going to work with directories. Okay, so if we are at a.c, what I need to read from that? If I'm pointing to a.c, what I'm supposed to read from there? File name, yes. But will it only have file name? Will it only have file name, or there are some other things also? It has so many things, right? Not only file name. So where all those things are stored, where all those things are stored, that we need to find out. Okay. So in direct.h, we have a structure. In direct.h, we have a structure, and the name of the structure is again direct. Right? Name of the structure is again direct. Have you seen that in the main page? Yes, good. Right? So first let us study the signature, and then I'll explain you the structure, right? How it works. Okay, so the return type is a structure pointer. Return type over here is a structure pointer, and the name of the structure is direct. Okay, so that is the basic thing. The function name is read dir, and then see what we are passing, right? Can you tell me what is this argument? Yes, can you map it from the earlier call? It is a directory pointer and it is returned by OpenDIR. Exactly. It is returned by OpenDIR. So whatever OpenDIR returns, and as we all know, OpenDIR points to the first entry in my directory. It points to the first entry. Now I need to fetch details of the first entry. I need to fetch the details of first entry, and for that we'll be calling readdir. Is that explanation fine? Clear? Right? We pass a directory pointer, and what we get is a structure pointer. We pass a directory pointer, what we get is a structure pointer. Now, what is there inside the structure? Okay, let us see that now in detail. Structure has multiple things, right? First thing is inode number, right? Now, in Unix systems, right, inode is a most important data structure as far as the file management is concerned, because if you say that your system has 100 inodes, right? If you say that if your system has 100 inodes, that means the total number of directories and files is equal to 100. I'll again repeat. If I say that my system has 100 inodes, right? That means I am having total 100 directories plus files. Is that much clear? Yes. So your system maintains an inode table, right? We are going to see this in memory management when we'll study that topic, right, in detail. Inode table. This is the most critical data structure for file management system. If your inode table gets corrupted, you will never be able to access your files, because your inode table maintains the memory addresses where your data are stored. Inode table maintains the memory addresses where your data are stored. So if your inode table is gone, you will never be able to retrieve the location of your files, the data of your files as well. Are you getting this? Right? So it is the most important data structure for Unix file systems. Right? So first thing that direct structure stores is inode number. Right? Every inode is assigned a unique number. Okay? For one file or one directory, there will be one inode number, unique always. Right? So as we are looking inside a directory, right? And as I told you, every directory has an inode. Are you following that? We are currently inside a directory, and every directory has one inode. Okay, so that's why the inode number is stored over here. Okay. Then comes the offset. So after I read the first record of my directory, that means after I read my first directory's details, I need to go to the second directory. Yes or no? After I read the detail of A.C, I need to go to B.C. Okay. So what is the offset from A.C to B.C? What is the offset from A.C to B.C? Are you getting the idea? Yes. How many locations I need to traverse from A.C record to B.C record? Define. Right, and that is called offset to the next direct. Offset to the next direct. Every record is called a direct. Okay, for A.C we have one direct, for B.C we have another direct, and so on. Okay, because after reading this, I need to go to the next one. So that is maintained over here as a D_OFF directory offset. Yes, on last file, what is the value? So it will be null ideally, right? It won't contain the value in that case. Yes. Right. Okay. Then comes record length. Right. Now, as you can see, this is a structure, right? And it has 5 members. right? So those 5 members will occupy some memory. Yes or no? Those 5 members will occupy some memory. Right? There are 5 entries. So what is the length of that memory? That is, what is the amount of memory that it occupies? That is called record length. Cleared with the third parameter? As I told you, right, this explanation will take some time. Programming, you will have enough time for that, right? Don't worry. Okay. Next comes D underscore type. Okay. This is a data type which identifies whether the current entry is a file or a directory. I'll again repeat. This variable defines whether your current entry is a file or a directory. Right? If it is a directory, then the value will be dt underscore dir. Those who have seen the main pages, have you seen this name anywhere? I have not written the complete main page over here. Those who have not seen, please open the main page and find out this from the main page and let me know whether you find this or not. Go to your prompts, command prompts, open the main page of readdir and just check it out. Can you see dt underscore dir over there? Yes, Kaushal is verified, Urjit is verified, good, right? If it is a directory, then it will be defined with this constant, dt underscore dir. It is again constant, right? Yes, this is a directory. If dt underscore dir is there, it is a directory. Okay. If it is a file, then again we don't need to store this value, right? Yes, dt underscore regular for regular files. Yes, Urjit. So there are many values, right, over there. It's good. Now the interesting part comes. From this 5 entries, what we are interested in currently? From this 5 entries, what is the most important thing we are looking at? This entry, name, ideally, right? Because right now, I assume that my directory is having all simple files, right? No directories. Okay. So in that case, I am just interested in d underscore name. Yes, Urjit, I think you got my point. Yes. So d underscore name and the length is also given 256. So can you tell me what does this length signify? 256. Guess and tell me what this value signifies. On your main pages, it is showing the same length. Just check it out. Maximum size, exactly. That means I can't have my file name greater than 256 characters. Right? So that is a restriction Unix has set up. Right? Exactly. So the last parameter is a file name. Fine. So what readdir does, let us now go in detail. On success, readdir returns a pointer to the structure as we understood, and this is the structure definition. Okay. And where this structure is declared, are we supposed to declare that in our program? What do you think? Are we supposed to declare the structure in our program? No. Why no? Because it is there in the header file. Very good. It is already there in dirent.h. So we can just declare its type. We can just declare its variable. Right? Okay, so don't do that mistake. No need to write the structure in your code. It is already there. Just declare a type like this. But direct pointer and b. That's it. This is what I need in my program. Yes or no? And then how should I call readdir? How should I call readdir? Can you write that syntax? Yes, that's right, yes, but that is for printing the name. But how will you call readdir function using this pointer? Yes, D is equal to readdir and FD, where FD is your return value of opendir. Yes, that's right. And how to access that? As Yash has written, right? We access the structure pointer variable using the arrow, right? We use the arrow notation for that. And all of you know that, right? And you have done it many times. So is the basics clear to you? Yes. Structure basics and theory. Okay. Now, if I want to read the next record, yes, exactly. I was going to come to that question. If I want to read the next entry, what should I do in that situation? What is your opinion? Think and give me the answer. I have called readdir once, right? If I want to call readdir once again, what we should do? Definitely a loop. Yes. Okay. So Yash has written D is equal to D plus E offset, but basically Yash, all these pointers are internally handled and they are advanced automatically. It is done by the system itself. Yes. As Krishil has written, it is the job of readdir only. That means if I call readdir once, it will read the first record and it will make the pointer point to the second entry automatically. Following this, I'll repeat once again. If I am calling readdir once, right, it will read the current record that is true. But after reading the record, it will set the pointer to the next entry. That means when you go back to the loop, you will be pointing to where? To the next directory entry. Yes or no? Clear? Yes. So that is the internal details. Read till pointer not null. Yes, that is one of the way you can try out. Okay. You all are good programmers, so I am not giving you that detail. Fine. That thing you have to try and tell me. Right? Okay. Fine. So if the directory, okay, just calling again and again. Yes. If you do it inside the while loop, as many times read dir will be called, those many times your pointers will advance. Yes, is that understood? Yes. So that is a simple logic, right? It's a very simple program. Only thing is we are working with pointers, so make sure that you are declaring them properly and you are using them properly. Because if we misuse the pointers, what we will end up with, and that I have seen many times in past with students, there is segmentation fault, right? And I don't want you to get that. Okay, so make sure that you declare the pointers properly. Plus, when you print the value of directory name, it should be properly printed. Is that fine? By using struct dir and dir, can we use directly? No, that won't be possible, Krishil. Because see, if fd is your directory star pointer, it is its data type is different, right? Yeah. See, you can write this fd is equal to open dir inside the read dir function if you want to make it shorter. Can we do that, Krishnan? Yes, right. But basically, what we require is a directory pointer. Okay, but right now you don't go for that shorter way. Keep the code simple. First, call open dir, right? And then whatever is your logic inside the loop, right? Inside the loop, you are supposed to call read dir and make sure that you are getting one by one directory names. Okay, is that clear to all? Yes. So suppose if your direct, let us say direct pointer is like this. Suppose I'll give you an example to make it clear. Sub direct EPTR. Right? If I have declared this pointer, and assume that my directory pointer name is D, right? That is dir star D. Okay. And if I have declared, let us say I have already opened, right? I'm not writing the open call over here, right? So after open, what we need to do is dptr is equal to read dir, and what we will pass as argument? Yes. Get it now, Krishil? Yes, yes. So again, I'm repeating. If you mix up the pointers, if you exchange the pointers instead of dptr, if you write d, you will end up with segmentation fault, right? Because we are dealing with critical data structures. Okay, so I don't want you to make that kind of mistake. So take your time. But what I want you to write is this. Right? Let me go straight at the aim now. Implement a program to list contents of current directory. Right? Implement the program to list the contents of current directory. And I think most of you are having your current directory as /home/user1. Okay. So no need to get it dynamically. Right now you go with a static file name, static directory name. Right? /home/user1. Pass it directly inside OpenDIR. You have already done that. Okay. And try to read the entries inside that directory. Okay. I'll show you the sample output which I'm expecting. And if you are clear, you can start programming. Right. Meanwhile, I'll show you the output. Yes. What comes in the question mark? That is D, right? D is written by OpenDIR. Remember that? Okay, user is completed. Nice. Yes. So I'm giving you enough time, right? Around 20 odd minutes. Try this, right? For this. Yes, Urjit, if you have any doubt, you can ask. Output. Yes, yes. I'll surely share that. Yes. Okay. So I think you can see my screen share. Let me just. Okay. You have printed in single line. Yes, that's okay, Bhavik. But you try to make it more formatted, right? In the remaining time. That would be better. Yes. So over here, what I've done is I'm reading the directory name. So I've tried to make this program customized, right? So suppose I'm entering /home, right? So it will return the directory contents of /home, right? If I go inside /home bash, that is my folder name, then it prints everything. You see the output? Use it? Yes. So see, we are getting all the entries, right? Dot, double dot. We don't mind that right now. It's okay. Those who have completed, Juzar and Bhavik, are you getting them also? Dot and double dot. Yes, so there is no problem with that. Don't worry. Later on, we'll try to suppress them, but make sure that you are having a properly formatted output. Yes, we are also having hidden files like .config, .bash. That's okay. Right now, we are not interested in suppressing them. Okay. Yes. Uh, I think someone's mic is unmute. Can you please check your mics? Can you hear some noise? Okay, okay, fine. Yes, so try that out. Okay. Yes, that's okay, Urjit. No issues. So I'm giving you time till 245, right? It's 230. Try that out. If you need more time, you can. And those who have completed, try to format your output in this time, right? Make sure that it looks proper. Okay. Yes, I can see some of you have already completed. So those who have completed, format your output. Okay, that is your next task. We want to make it look similar to LS, right? You can even customize, right? It is not necessary that it should be same as LS, okay? But make sure that your output is presentable. Fine. 15 more minutes I'm giving, then we'll continue. Yes, Janil, if you are getting that, make sure that your directory pointers are properly used. Recheck your code once. If still it is not happening, make a copy of the same program because this program's memory has already corrupted as you are getting segmentation fault. Okay, so you might have to copy this program in other file. Okay, check the code once again and retry. Okay, this can happen, so don't worry, right? It happens because we are using and we are dealing with inodes and directory data structures, right? Yes, sure, Jenny. You can send me the mail as well as, meanwhile, as I told you, you create another file with the same code and check your code once again, right? So those who complete, keep writing your status over here so that I can gather the status and then I can know when we can go ahead. Yes. So I'll wait for most of you to reply this, right? Because this is an important program and I want all of you to try. Right? Good, Jenny. I'll just check it out and meanwhile you can try. Yes, Kaushal, you can also do the same thing as I told you to Jenny. Check your program once again for pointer declarations. Right? Make sure that you declare them properly, use them properly. If you feel it is all right, copy the program in another file, right, and then run it once again. Because a segmentation fault means your memory has got corrupted. Right? So you won't be able to use that program once again unless you flush the memory. Right? Yes, Mr. That's not the issue because we are not running or applying the sorting algorithm over here. Right? LS internally might be sorting the details, so that's okay. But are you getting the same entries? Then it is okay, right? Except the hidden files, right, that we are ignoring for now. So again, we can appreciate the yes directory pointer ptr is equal to open dir x. Yes, and x will be the, yes, exactly. It is the path. That's correct, Priya. Yeah. But I recommend that you declare your pointers at the beginning, like we do in C, and then use them, so that we can be consistent with the code, right? Declaration and calling you can keep separate, so that the code is clutter free. So meanwhile, I'll switch back to the lab menu for the screen share. You can do that, yes. And ls does the same thing, yes, strcmp. So we should try to get as close to ls, right? That is the goal. We should try to get as close to ls output. Good, good. So as I told you, those who have completed early, focus on the formatting part, right? As uh, as Vishnut has already said, if you can skip the dot and double dot, right? So that your output is as close to the ls. Right? So spend some time on formatting the output. Once you feel it is formatted, take the screenshot of your program and the output, okay? So that you don't have to invest extra time. How ls manages too many arguments? I don't think, right, with if else for all options. Yes, for that we need to look at the code, right? So in your free time, you try to access the code of all these Linux files and then just have a look at that, right? That will be interesting. How to get number of directories? Yes, so directly we won't be able to count generally, but it will automatically advance to the next directory, right? So we don't need to worry about that, right? Read dir automatically does that, so we don't need to worry. Yes. Okay, it's good to see that most of you are giving me done status, right? And not the segmentation fault. Very happy to see that. Good, good, nice. So it's very easy, right? As of now, what we are writing, just using simple set of functions, we can actually write the operating system functionalities, right? And that is what this programming makes more interesting. So meanwhile, we'll discuss closed dir also. The others can focus for 2 more minutes over here, then you can continue with your program. Closed dir is just like a close function, right? Whatever directory stream you open has to be closed properly, right? Because if you don't close it, right, then what will be the disadvantages? Can anyone tell me? Those who are done with the program can answer. If we don't close the open directory stream, that means actually we are accessing an OS data structure right now. And if we don't close it properly, what might be the issues? Yes, those 10 to 15 students who have completed can answer. Changes are not reflected, possible. Yes. Basically, your memory pointers won't be in proper position. Yes, that's right. Memory pointers won't be in proper position. So if your system or terminal closes down and you once again open the terminal, then everything might get normal, right? But if you continue using the same program or same terminal, basically same process, right? Then you might have memory allocation issues. Agree to that? Yes. So that is why whenever we open the directory, yes, you may not be able to open file exactly because the memory might also be occupied by all those things. Because every time when you open a directory or a file, you are actually allocating memory, right? And if you are not using that for a long time, then unnecessarily you are occupying the main memory, right? And that is not good. Okay? So always it's better to close the directory stream, right? And the function for that is close dir. What is the argument again? It is the same pointer which you are using in open dir. Okay, so the same pointer name you need to pass. Header files are also same sys types.h and direct.h. Okay, if you are able to close it successfully, right, then it returns 0. If you are able to close it successfully, it returns 0. Otherwise, it returns with -1. Otherwise, it returns with -1. Is that fine? You all close dir? Yes. Okay. I hope all of you are listening to me right now. So, have you added this function in your program? Yes, when -1 will occur. So, when the directory might already have been closed by the system, right? That might also happen, Shaggy, because the system required the memory, right? So, it took away the memory occupied by that pointer, right? So, system might have already closed that directory, right? It is possible. So, in that kind of scenario, -1 can be returned. Or else, you are trying to close something else, not this actual pointer, right? You have opened the directory pointer with d name, but you are trying to you are trying to close d1, right? And d1 might be pointing to something else, right? So there are many scenarios actually where -1 is possible. Okay, and your system maintains an error table, and inside that error table, one entry will be made with an appropriate error number. That's why you will see this line: error number is set appropriately. Right? So for every type of error, a unique number is assigned. So that number will be set up against that entry. Okay. Yes. So all of you are clear up to this. Open dir, close dir, and read dir. We have seen three important functions. Yes. Okay. So now we have 35 more minutes, right, before the before the lab completes, right, and that is enough for writing the next program, right. Next program is recursive ls. Have you tried this ls capital R option? Just do that on your terminals and see what happens. ls-r. Yes, subfolders are also displayed. Is it happening in your current program? Those who have completed, is it happening in your current program? No. Right. So that is the change you need to make. Okay. So I'll give you a simple idea. What you need to do is you need to check whether it is a directory or not, whether the current entry is a directory or not. If it is a directory, you go inside. Okay. Otherwise, you print and exit. Otherwise, you print and exit. Is that fine? Basic explanation. Yes, using the type. Remember that structure, this structure definition, p underscore type. Yes. So you need to compare whether the current type is a directory. How do we compare? With what we need to compare? dt underscore dir, right? Refer to the main page in your systems. Refer to the main page for that and find out how we can achieve this task. ls recursive. Okay, is the basic aim clear to all? Yes, and I think it will take around 30 minutes, right? So we have enough time. So take your time and complete this task. Okay. So in total, as I told you, we are going to write 3 programs. The second program is already written. You already written basic ls for current directory. Your third program is this ls-r. Okay. You should get the similar output that you are getting with ls-r. Fine. So try doing that. By the end of the lab, uh, try to complete. Okay. And meanwhile, I will also upload this PDF in the classroom with the assignment. Okay. So you can refer to it. if you have not joined the classroom, do that right now so that you can access the material, because out of 180 students, only 175 have joined. So those 5 which are left, please share this code with them so that they can join, right? I have posted the assignment link as well as the link for the document. Okay. Okay, so yes, Bhavik has completed. So I'll explain what has to be done next, right? So basically, we have written 2 separate programs, right? But you can combine them into one, like what LS has done, right? So inside LS, if you just do LS, it prints the current directory contents. Is that fine? Is that correct, Bhavik? If I do simple ls, it gives working directories contents, right? And if I do ls-r, it reads my command line argument, and based on that, it runs the recursive code. Okay, so those who complete this code can try for that. Combine that code into one, right? Combine the code into one solution. A single code for ls and ls-r. It is an assignment problem, right? So if you complete these C programs before time, this assignment problem you try out. Okay, and if you complete that, you also submit that, right? Is it fine, Bhavik? Did you understand that? And others, I hope you are listening as well, right? The solution logic is already there on the screen share. What I explained, it was already mentioned. So please go through that and let me know if there are any queries. It's fine, Krishil. You can go with unsorted output right now. But yes, if you complete this combined program, then it will be an extension, right? That means if you are done with a single ls program which does ls and ls hyphen r both, then you can try out that sorting as well. Not compulsory. Okay. Yes. If you have time, you can try that later on. But first job is to combine both the programs into one. That is a priority. So Priyank, you are supposed to compare that whatever is return value of d underscore type with dt underscore dir, right? And if the match is there, you can continue, right? No need to cache. You can directly do the comparison, right? Again, it is a constant, right? It is a constant. So you can easily compare with the double equals, right? Like we do always in standard programming. And those who have not submitted the lab 1 assignment, do that uh, today itself, right? So that it is not considered as late submission. If it is still pending, do that today itself. Uh, yes, Shail. So the only effective solution for segmentation fault is we can have a look at the code thoroughly, right? If you feel that you have forgotten the star or asterisk somewhere, or if you when you are trying to print the directory name, uh, if you are not using that arrow notation properly, right? If you mistype something extra, that might be cause. Declaration part we need to check whether we have declared a directory pointed properly or a struct direct pointed properly. Okay. If everything is fine, then this other solution is you copy the same code into another file, because segmentation fault occurs because you are accessing unallocated memory. Right? You are trying to access unallocated memory. So the issue can be resolved if you try to copy the code in another file if you feel that code is correct, right? And run that new file. Okay. So you will have to trace your code basically. Right? That is the first thing you need to do. And as I told you, these are critical data structures. So if we misuse any of the memory location by mistake, it will definitely result into segmentation fault. Right? So try to debug it. Right? Try to go through it once again. Yes, Aditya, you can use printf right now because printf again internally calls write system call. Okay, so just for printing purpose, we can use printf itself. Yes, because for write again you will have to declare the buffer, right? And from that buffer you need to read the number of characters to be printed, right? So the code can get complicated if we go with write, right, in this situation. So it's better to go with library function because printf will handle internals automatically, right? So I hope the basic logic is clear for the recursive ls, right? You are supposed to check whether it is a directory or not, right? By just comparing your current value with dt underscore dir, right? If it is a directory, then you need to go inside, right? Go inside means you need to generate a new path. Okay, and how to generate the path? You can use the concatenation and all those functions, right? And using that, you go for reading once again. Okay, if it is not a directory, you can simply print the name and exit. Right? So it's a simple recursive function again. Okay. But while doing this, if your pointers are not advancing properly, you will encounter segmentation fault, right? So we need to be careful with this. Okay. So those who have completed can type in ls-r done so that I can track the progress before we end the lab. I've seen the earlier responses, but those who have completed right now can respond. Okay, halfway. No problem, Arjit. Continue. I hope the logic is clear, right? It is about the path generation, right? Path generation and going back in the function. Yes, so again, we are discussing just one option. Think about the real complexity of uh, all the options, right? So again, I'll keep saying that we should appreciate the complexity of the OS, right? How it is written actually. I hope all of you are able to understand that, right? But once we get used to these functions and system calls, the jobs will get easy, right? So it's about time. So if there are no queries, then you can leave the meeting. Okay, Kaushal is asking question. We have to add two programs on single working for both in PDF. Yes, so see Kaushal, if you have completed first three programs, right, then the combined program will be your fourth one, right? So total you can submit four programs, right, in the same PDF. Okay? Yeah. So fourth one will be combined. Yes. All right. So you can leave the meet now if you are clear, and have a good day ahead.